in LLM context window. So if you understand, like when you type in, when you submit something to the LLM, so that's called, see that chat window, it's a context window. So how much information you can stuff into context matters, because let's just say you can consume a lot of information, you can give it a lot of information for it to process, then the better, right? You're providing it more information for it to understand its surroundings. Think of it like, let's just say you have a problem that exists, and in order to solve that problem, it needs to know its surroundings. Let's just say its surrounding is very limited. Then, of course, in order to solve that problem, it gets more difficult because there are a lot of ambiguous information that the LLM needs to figure out, which introduces problems. It will introduce hallucinations into solving the problem, like it will make educational guesses. But if that context window, the information that you stuff into it has a lot more information, let's just say it has a complete code base that is pretty well documented, and the code is good, then that provides context to a specific problem, let's just say in your code, and so it can reference other parts of the code base to generate the solution. So for example, if you look at Gemini, you look at other LLM models, their context windows are getting larger and larger, and the idea is that the larger the window, the better it is. But this is a part of what I'm trying to address, is the fact that the context window itself is not is important, but at the same time the quality of the information in context is important. So I believe that if the quality of information in ratio of crap versus good information is high, that means they just say, so in this instance I'm saying crappy info over good info. If this is high, which means that there is a lot of crap, then in order to solve the problem, it doesn't improve that much. So let's just say, for example, just think of it this way. Let's just say your context, you have a problem of saying what is 1 plus 1, and then you stuff the context around it with a lot of information where 1 plus 1 does not equal 2, so 1 plus 1 equals a whole lot of different things. And in order for it to solve this problem, it just understands that based on what you're providing it, that context is what's being surrounded with, then the answer would not be 2. It will be probably some other educational guess based on the context. And then, on the other hand, if you supply it with less crappy info with a lot of good information, then the chance of it providing you with an accurate answer, 1 plus 1 equals 2, like it'll show you like 2 apples, like 1 apple here, 1 apple here equals 2 apples, or whatnot, whatever illustration it can be provided, then it'll understand and start to pick up what the idea of 1 plus 1 equals, which is 2. So that's essentially what I mean by the ambiguity and clarity ratio. So I do think that if this ratio does have an impact, which means that it doesn't really matter as much with how large that window is. Of course, the larger the window, the better, but I think the larger the window also comes with greater ambiguity in potentially, depending on whatever you're trying to solve. Let's just say if it's a code base. I mean, if you're creating something new that the code itself doesn't have reference to, then I'll just probably need to make some educated guesses. And in order for you to reduce those educated guesses, then you need to create some more documentation or provide additional info that can clarify those areas that have problems in its clarity. And while I'm using this plan mode in cursor, it looks like that's kind of what it's trying to do as well, to reduce that ambiguity part of the problem, which is cool because I think it does a lot of the things that I talk about, which is essentially reducing the ambiguous issue, which, if you look carefully, the ambiguous problem is everywhere. You can look at, even if in my docs, I'm sure there's a lot of